So Vlad and I will be talking about chaos engineering, resilience testing, the idea of intentionally causing failures to to test your resilience to them. So I'm Laura Thomson. I lead the product management team within AWS for our reliability services, and that includes one called fault injection service that enables chaos engineering. Here's Vlad.
Yep. Hi, everyone. I'm Vlad. I'm one of the principal solution architects in AWS Global Financial Services. As part of my role, I primarily deal with huge global financial institutions, likes of HSBC, Barclays, and big insurers. And that's how I came to work really closely with Laura, because all those banks have quite a heavy focus on reliability and resilience of their services. We will start today from top 3 questions that we have heard from our customers across the globe. Any guesses what those could be? Yeah, they're all related to, what is chaos engineering? That's a good one, yeah.
We should add that, absolutely.
Any other ideas? Yeah, you get a point, yeah. Yeah, that's really a good one. But actually, to the point what chaos engineering is, we actually have been asked a lot, where or how do I start? Despite this SRE chaos engineering resilience topic being quite a popular topic, there are a lot or decent amount of organizations that still try to figure out what it is, how they can kick it off, how they can upskill their teams, how they can build up a team that can actually lead chaos engineering or resilience testing function in their organization. On top of that is question if they need to do it in production. And that's where we might have Netflix to blame, because there are quite a lot of people who heard that they are doing chaos engineering in production, but not everyone actually read the whole story on how did they get there. And doing stuff in production, especially for traditional institutions, is really scary. So we will talk about this as well. And lastly, we will speak about the money. When you want to do something, you have to pay for it. And then you have to essentially convince your bosses that you need those money. So now, before we dive into those questions, I'll pass it to Laura to talk about history of chaos engineering in Amazon or AWS.
All right, so we're going to start with a story, another story for you this morning of extreme events. So we'll think back early 2000s, there was an engineer at Amazon called Jesse Robbins, and he was tasked with making sure the Amazon retail business was ready to handle peak events, peak sales events like Black Friday, which is long before Prime Day was even a thing. And Jesse had a pretty unique background. So before Amazon, he was a firefighter. And as a firefighter, before you go into a live fire, before your active duty, you do a huge amount of training. And even after your active duty, you spent over 80% of your time in training. And that's because when you go into this event, you need that really good judgment and strong experience to make the right decision quickly under a lot of stress. And bringing that perspective, Jesse implemented a really similar training program for Amazon engineers to prepare to handle extreme things during his events, which was really a form of early chaos engineering. We called them game days. Talk a little bit more about game days, but essentially thinking about, okay, I have my application, I have my service. What does my steady state look like? Which is, what is happy? What do I expect to happen if things go wrong? And then we run the experiment, we run the chaos engineering. And that might be creating events like a data center going down and availabilities are going down. Have my people respond? Have my systems respond? Is that what I expect? And after we run that experiment, there's the investigation. What went really well? What didn't go so well? How can we get better? And creating actions out of that process. And although this isn't super random chaos, the name is a bit misleading in that we're being really intentional about what we expect to happen and then creating that test, reading that training for our team, our applications to do it, to see if it works the way we expect. And thinking about a building under wind load that I talked about earlier in the keynote, it is like thinking about all the things that could happen. A hurricane could come and it could have this wind angle. Are we ready? And here we're thinking about that for our applications. What are the things that we've designed to handle? And then let's make sure that it actually works that way.
Yeah, Laura, it's actually quite a lot of information, but I'm sure we have something to offer to make it much easier.
We do. Thank you, Vlad. So Amazon and AWS have done this for a long time. It's really foundational to what we do before we launch features, before we launch services, even new geographic regions. We go run game days, we do chaos engineering as part of those preparations. We see more and more customers bringing their most critical workloads to AWS, so it becomes really important that they're also doing this type of game day chaos engineering practice. So a few years ago, we launched a suite of services under Resilience Hub. One of those is fault injection service. That's our service to run these fault injection experiments. When we built the service, we talked to a lot of customers, some customers who were doing chaos engineering already, but a lot of customers who weren't, but had systems built on AWS that needed to be resilient. So understanding where they were, how we helped them get started. Teeing up our first question there. So 3 things we really focused on was getting started. So how you help figure out, okay, based on my application, what experiment should I run? Where am I going to get the most value? What has use for me? For that, we have some built-in scenarios, basically predefined experiments for common use cases that you can basically select, define your application, define the resources to be implemented and run it. So starting with that play part of the game day as part of the experiment. The other was real-world conditions. So the customers that were doing chaos engineering already could do some things themselves. So using public APIs, misconfiguring things. So maybe you can't scale in a certain availability zone, things like that. But there's a lot of value in being able to create more realistic type events, things like storage volume getting stuck. It's really hard, kind of impossible to do yourself. But because we're an AWS service, we can go work with those service teams, integrate really deeply and do things like creating a stuck volume. And then the last is safeguards. So I mentioned a little bit about chaos being scary and that it's not really supposed to be chaotic. So that's really something we wanted to bring here to this service is building in the safeguards, things like you can set alarms, monitoring, that if it triggers, we automatically stop an experiment, we roll everything back. There's a big red button that can shut everything down in the account so no experiments can run until you give the go-ahead. Really emphasizing that like should be really in control of it and preventing anything from being chaotic. Here's a little peek at the scenario. One's that easy availability power interruption scenario. A really common when we see highly resilient applications building across multiple availability zones, essentially multiple geographic locations that are isolated. So as part of demonstrating that this is really going to work the way you've designed it to run an experiment like that. The next one is a bit more forwards looking. So it's about workloads that are built across multiple regions, which isn't super common because for most workloads, availability zones are sufficient to give you the reliability you need. But for things like I mentioned, working with some financial institutions that have a regulatory requirement to be in multiple geographic locations, we typically look at, okay, if you're building for multi-region, what are the experiments that have the most value? So this one's designed to help you identify dependencies that you may not realize you have between the regions when you run, say, a practice disaster recovery from one region to another. If you're not actually isolating the region, you could have dependencies across them that you just don't know about. So an experiment like this helps you uncover those types of things. All right, so with that context, we'll go back to our 3 questions and think about, all right, now where do you get started?
Okay. So when we think about the starting points, usually it's quite important to think about your goals. What is important and what you would like to do with that. At the very beginning, you will start with your personal problems. It may be your team, maybe yourselves, but it will be small in scope, things that you would like to improve. And for chaos engineering to be successful, you have to transition those learnings, those experiments, those success stories to broader organization. And ultimately, you have to get leadership support in defining those goals and their measurement. If you don't do that, it will be really hard to justify your existence. And when you think about those goals, we put user experience at the top. That's a paramount in Amazon or AWS, but I think it should be paramount for every other organization. If you think about availability, metrics, probably everything apart from compliance, all of this will be impacting your customer experience. And your customers, either internal or external, or maybe it's even other systems in your organizations that consume your platform or your system, their experience should be as smooth as possible. However, being in financial services, compliance plays a role as well. It's not necessarily something that you would do to justify improvements, but you have to provide evidences to regulators that your application or your services can sustain certain degradation without causing intolerable harm. When we think about chaos engineering adoption, your ultimate goal is to reach a stage where you do continuous experimentation. So at any given moment in time, you're confident that your application or your services or your platforms can sustain certain level of degradation without impacting your users. And at this stage, you're getting reassurances on hourly or daily basis. However, what lots of customers didn't really pick up on was the simple matter of fact that even at the very beginning, at your initial adoption stage, you're already getting a benefit. You're getting a benefit even before you run your first experiment. To prepare for chaos engineering, your teams will be looking at your application. They'll be trying to figure out what they can break. And all of this will lead to better understanding of how their platform's application working and what are those components that can actually cause a fault. This is an example of goals or targets that has been set by our Prime Video team. They went through their services. They went through the scenarios that can cause an impact to their end users. And this visualization represents amount of their experiments that they run for a particular scenario. As you can see, majority of the scenarios they do run related to networking, which I think is quite an obvious thing for a Prime Video, which is streaming service. And that is something that you should aim to build up on your chaos engineering journey, understanding of your most critical components and how you can test or validate them. So now let's talk about scary stuff. And Laura will walk you through this.
So our next question here, do I need to do this in production? So with what you've learned so far, what do you think? You need to do it in production? No, you don't need to do it in production. So there is a lot of value in doing it in production, but also if you think about Vlad's point about how much you can learn in that early adoption, just the planning stage, there's also a ton of value in running it in a test environment. A decent environment you can use that's at least close-ish to production, but you'll learn a ton starting there, which probably because of Netflix and Chaos Monday, I don't know. But we see a lot of folks coming and they haven't done anything because they feel like they can't do it in production. It's too high risk and it shouldn't be a barrier to getting started. Like they can learn a lot without being in production. That being said, there are reasons you would want to run it in production, mainly that prod is likely pretty different than your test environment. So it's a higher fidelity, a better test. Some ways we've seen customers and internally do it well. So last year we worked pretty closely with BMW's connected car division, and they were getting started with using that easy availability scenario. Connected car is basically important that they have high availability. And what they did is they ran the scenario a few times in non-prod, ran it, learned some things, fixed it, ran it again, learned some things, fixed it, ran it again. And once they were really confident that it was going to work, then they ran it in production during off-peak hours and had a really successful test doing it that way. And it was a way to mitigate the risk, but still run it in production. Something Amazon Search does, they do the search bar on Amazon.com. And they have a budget for availability, and they budget in chaos engineering impact so that they can run it in prod, but have a very small impact on their availability that they've decided is acceptable. A third way we see folks set up, call it a shard, basically an isolated part of production that only receives synthetic traffic and running the chaos experiments there. So you don't need to maintain a completely different environment. It's identical to prod, but you do have that isolation that gives you that playground where you can run these. So don't need to do it in production, but if you want to, and there's good reason to, there's some options to mitigate that risk. And our last question here, so thinking about return on investment, the money.
That's talking about the money, and that's where I regret that I didn't put a slide with a meme here. So when we think about return of investment and where and how you would want to do your chaos engineering, if you will come to your managers, to your bosses, and they'll say, I want to break stuff, they most likely will tell you, oh, we have this like a tier 4 bronze application that no one's really care about because if you do the down for 48 hours, for several days. We would not even notice. Yeah, go and do it there. And it may be a right approach to get started, to build up your muscle. Like Laura's point, you don't want to break the critical stuff in prod straight away, but you want to understand how to do it. You want to build up your experience, your mechanisms, your tooling. But no one will notice any improvements there because no one cares. Your ultimate goal should be your tier 1 applications. It doesn't have to be prod, but improvements, those findings that you will do or you will uncover in your lower environments, they will be noticeable because you can present them to your management. You can essentially see how much of impact they could have caused your organization. And that's where you can actually connect them to a money value. Ultimately, your path is to transition from goals to something that is more measurable. It can be economic considerations. It can be customer experience. But what we think or what we observed you should be very mindful about are those two things. Essentially, they are quite close together. Lots of organizations, like with cybersecurity, they invest in chaos engineering or resilience testing after something has happened. Like probably after the building almost collapsed, they spend lots of money on welders, as they had to do very quickly. But in a few years, everything's forgotten. So the team probably of welders have been fired and they went to do their own things. And at the same time, if you do too good job, you will have this prevention paradox challenge. A good example one of our colleagues gave to us was year 2000, when before year 2000, there was lots of panic saying, oh my God, those computer systems will collapse. And then nothing happened. And some people said, it was just nonsense from those tech guys. There was no impact. But it's not true. There was no impact because lots of people worked really hard to make sure that there is no impact. What they probably didn't do too well is they didn't highlight their achievements. And that's exactly what we suggest our customers to do. If you made an improvement, make sure that your top leadership is aware of this improvement, even if it didn't cause an impact. Celebrate your wins, celebrate your improvements, and do everything you can to advocate for yourselves or for your teams in your organization. So everyone would know that your efforts, while not necessarily visible, they actually improve your systems. And we will talk about Lambda now and how that team did something similar. They moved from a goal to a measurable ROI. If you think about Lambda, how many people actually use Lambda? Can you raise your hand? Okay, not everyone. For those who don't know what Lambda is, it's a serverless function. You don't really configure anything apart from language that you use. You put a piece of code and it runs in a resilient manner. So Lambda will be executed across multiple availability zones. I actually made a mistake. Those should be zone 1, 2, and 3. So it's not the same availability zone. But here we are. And Lambda team need to ensure that your request will be executed, that it will not result into inability of execution of request. So there is a health check that monitors every availability zone. And then you as a customers will be sent to one of those. So what will happen if there is a bad day and there is something happening with those EC2 instances that underpin Lambda functions in one of the availability zones? So Lambda team has set a goal. They wanted to ensure that they will minimize the impact and they will divert all the traffic from impaired availability zone into healthy ones. They used fault injection service to inject faults. And what I say is they still using it as a continuous process because they are at the stage where they run it continuously. And fault injection service will cause an impact on that availability zone, making it unhealthy. And that will cause the Lambda to stop sending requests to that availability zone. After experiment is finished, it will be recovered to a state where it was. So that's another duty of the service. And when we look at the results of Lambda team, when they started this exercise, it was about 30 minutes for them to realize in an automated manner that availability zone is impaired, which is not great for customer experience.
I'll jump in and just say, so they set a really specific goal. Their goal was to be able to evacuate the AZ in less than 5 minutes. So it was a process where they would run the experiment, see where they were, how quickly they could evacuate. make improvements, rerun it, remeasure it, and that.
It's just about also. Yeah. So I think, it's a very good point because they didn't achieve it in one go. They run this continuously, uncovering things that prevents them from doing it faster. And ultimately, they went above their goal, dropping it to 3 minutes. And you can see it's a great reduction of the time. It's like 90% of their evacuation. They do it still, so they still uncover some of the blind spots that they were not aware, or they didn't monitor efficiently, or their health check was not picking up as efficiently as possible. And lastly, this is a metric, or this is a measurement that causes a direct customer impact. So if you would like to do something similar in your organization, what I would like to ask you to do is to find that metric, something that is easy to understand, something is really transformable into monetary measurement, and then focus on that one thing. Don't expect it to happen in one go. You will essentially have to go through iterative process to be successful. So that's all we have seen from 2024. Now let's talk what we think will be happening in 2025.
All right, so we were having to think about trends we're seeing and what we think is going to change in the space in the next year. So the first is regulatory and business mandates. A lot more of this attitude of, okay, great, you're building for resilience, but prove it to me, show me. So in the regulatory space for financial services, a regulation went into effect just this past January called DORA that's requiring scenario resilience testing. It's pretty open-ended in terms of it's up to the organization to define what scenarios they are resilient to based on their specific application, but there is that requirement to prove it. We're also seeing it in other sectors, even led by business leaders of, all right, we have this critical application, maybe at every plane in our fleet requires it to take off at Heathrow, something to that level of criticality. Now prove to me that it's actually going to work. So seeing more of those prove it mandates. The second, there's been some Gen AI progress around incident investigation, operational investigation that's really helpful during events, that it'll deep dive on your telemetry, pull out insights, help people figure out what's going on more quickly. And I think it'll be really useful for chaos engineering and getting the insights after the experiment. So now it's pretty manual, customers digging through logs, dashboards to understand what happened during an experiment and extract the learnings. So using Gen AI to do that investigation, just like you would during an operational event. And then the last, cyber resilience. So we're starting to see more and more customers use chaos engineering, use fault injection tool to also prove it with their preparedness for cyber attacks, heavily driven by increase in ransomware, DDoS attacks, and wanting to not just prepare for them, but also build confidence in your people to respond during the event and have that increased level of confidence that your systems are going to work the way you expect them to during a real event. All right, with that, say thanks for listening to us and raising some hands and getting some feedback. That was great. I think we have about 5 minutes for questions. This link here also is for a survey. We love feedback, so let us know how it was, what you learned, anything we can do to improve would be awesome. And then when we share the deck out, we also put some extra resources at the end, some documentation, some white papers that are pretty helpful for getting started with this stuff or improving good processes.
So any questions?
Hi. Thanks a lot for the great presentation. And I have a question about generative AI, the one that you showed one of the last slides. So will it be like extension for Amazon Q?
So Amazon Q.
So it's not a promotion for AWS.
I think it was at reInvent towards the end of last year. Q released an incident investigation capability. It's in preview now, but you can go have a look. It's tools like that would be Amazon's offering, but do the incident deep dive with Gen AI.
Perfect. Thanks a lot.
Does the tool have the ability for you to be able to run what I would call core suite of fault injections that you'd want to run across product teams? And then obviously you're going to allow for targeted specific product fault injections as well. So essentially, do you get a catalog that I could choose? So if I work for product team A, I have to be able to run the core organization-wide fault-tolerant tests, but I also want to run my own.
Yeah, so we call them fault actions. So it could be network latency, packet loss, step volumes, your catalog of things you can do, and then you can create templates out of multiple actions. So what we see organizations doing is based on the tier of an application. They'll say this tier is required to run maybe these 3 tests. And then application teams can also run whatever other additional tests they want. Is that yeah.
But even we add for basically financial institutions I'm working with, they actually have some of their pre-built scenarios for tests that will be mandatory to execute. So teams will be told, like, easy power impairment, you have to do it twice a year. And then you can do anything you want to improve your application. And those are like extra set of tests that you have to run maybe once a year, or central team will execute them on the behalf of application team at some point. If it like tools allows to do it very flexibly.
All right, so first of all, this is a very impressive collection of stickers in your laptop. It basically covers the whole thing, so I'm very impressed by it.
Thank you.
My question is, how did you guys get away with continuing to call these chaos engineering? Because everybody I spoke to had to basically rebrand to some kind of variant of reliability engineer because of the marketing program. How did you get away with not doing that?
So I think that we didn't. We actually position chaos engineering and resilient testing alongside each other, with the stress for chaos engineering being a bit more experimentation and resilience testing being a bit more like a structured process. But what we have discovered, lots of stakeholders, especially in traditional organizations, they're really scared of the word chaos. So they more prefer to use like resilience testing, but we're also trying to be cognizant there is like a market or like industry naming that we don't want to get people confused with. Do you want to add?
That's true. Like we kept it chaos engineering because we're talking to SRE folks and we assumed that people had at least heard of it before. But a lot of times, like when our SRE folks, as we are talking to regulators or talking to business leaders, the language changes so that you help them understand what you're talking about. So I think a lot of it's the audience, but it's often the same thing.